Now, sometimes I will kind of do step 1 and 4 together, depending. But those are your 6 steps. Oh. You want to take a picture of that and insert the picture? You want to take a picture of that and insert the picture? You can do that.
I'll just rewrite them.
Okay.
It'll just take
No!
like an hour. These are so slow. That one should
Maybe
go
just
like
go some way.
No, I think I know.
It also
I'm gonna
might have
face
taken
them
so
on
long.
ways into What do you want, boy? Who's that?
Mine's at 100%.
Open your hand, I'm not being too. Who's
I'm
this?
so proud of it. Okay, you're always recording 6 minutes.
Yeah. Okay, you know what I'm trying to.
Okay, do we have, I know you don't, my baby. Do we have the rules written down? Just tell me what number this is a big group.
How's Andrew?
Okay. Okay, so let's do the 6 steps for this problem in example 1. Now, some of the steps have been done for us, which is awesome, okay? But I just want to kind of label the process so that we can find it later on, okay? Here is step number 1. What are the inequalities? They were nice. They gave it to us. Yay. Okay, so step 1 is done. Step number 2, graph the inequalities. That's been done for us as well. Yay. Step 3, label the vertices that the region creates. So the endpoints of the shape, whatever it is, okay? Step number 3 has been done for us. Hooray. Step number 4 was to find the optimization equation. That's this equation right here, this f of xy. For the first time, you might have seen a function that has both an x and a y in it. So that's a little bit different. So step number 4 is done for us. So now, the first step we're going to have to do for example 1 is step number 5. So step number 5, write down your optimization equation. Okay? Write down your optimization equation. Underneath it, we're going to list in any order, doesn't matter what the order is, these 4 points underneath it. So I'm going to do f of 0.6. I'm going to do f of 1.53. I'm going to do f of negative 3.3. I'm going to do f of negative 2.6. In any order. In any order, okay? So I like to write out the function, and then I like to write, So I like to write out the function in any points directly underneath it, okay? Now, let's do the math. So, just think, if our x was this and our y was that, we got to plug it in. So every x we're going to multiply by 4, every y we're going to multiply by negative 2, and then we'll combine it. Just follow order of operations. So 4 times 0 is 0, minus 2 times 6 is negative 12, 0 minus 12 is negative 12. Now we're going to stick in 1.53. 4 times 1.5 is 6. Negative 2 times 3 is negative 6. 6 minus 6 is 0. Now we're going to plug in negative 3, 3. So our x is negative 3, our y is positive 3. 4 times negative 3 is negative 12. Negative 2 times 3 is negative 6. for a total of negative 18.
Yeah, that's what selection was.
Lastly, we're going to plug in negative 2 for our x and 6 for our y. 4 times negative 2 is negative 8. 6 times negative 2 is negative 12 for a total of negative 20. Now we're on to our last step. Our last step, step number 6, is to label our largest value as our maximum. Weird about this one. This is our maximum. Label your smallest value as our minimum. This is our minimum. And that is our first optimization problem.
That was so many steps.
Yeah, and they did a lot for us too.
I know.
Okay, so let's just go over one more time what happened. They either give us or we have to find the inequalities. Then we're going to graph them. We're going to find the feasible region, which is the region where all of their shadings overlap. We're going to label those endpoints. That's step 2 and 3, the graph and labeling the endpoints. Then we need the optimization equation because we need to plug in those endpoints into it. Label your largest value as our max, our smallest value as our min. That's the steps of an optimization problem, okay? Now, for 3.5a, I am going to give you the steps or the inequalities. So I will probably give you the inequalities in the equation, so you're going to have to do steps 2, 3, 5, and 6, okay? So speaking of that, let's do one that's just like the ones for the homework, okay? Let's take a look at example 2. Now, example 2 says, graph the constraints, then find the maximum and minimum values of the function f of xy equals 2x minus 3y. And the constraints are just our inequalities. X is greater than or equal to 1, y is greater than or equal to 2, and x plus 2y is less than or equal to 9. Okay, now let's go through our steps. Step 1 is what are our constraints or inequalities? Well, they gave those to us. Yay, that's one thing we don't have to do. Okay. Step number 2 is to graph them. So let's graph them. And here's the problem when you're working on a device. My device has an auto line straightener. Yours doesn't. So sometimes you may even want to put them into Desmos and then look what your picture is so that you can find that feasible region exactly. So, because yours might be a little wonky. Okay. So that being said, let's do this first one here. I'm going to do in red, okay? That is a vertical line when there's only an x. We know that hopefully. When it's only an x, it's vertical. Go over to an x value of 1. Make a vertical line at x equals 1. And I'm going to shade only a little bit to the right. Now, the reason I'm not going to go crazy with my shading is because I really want to, or you can even make yourself a little note that there's the shadings this way. Okay. Now, the next one I'm going to make in blue. So this one here is only a y value. So that is a horizontal line. So find a y value of 2. Make a horizontal line. Try to be as careful as you can with your graphing. We need to shade greater than, so it would be on this side. And you can even make yourself a note that you're going up. So if we look at where they overlap, right now, we are just in this corner. So sometimes I'll even erase my original highlights and only highlight the overlap, because you really are concerned about the shape that the overlaps make. And if you have so many colors on there, it just becomes kind of a little hard to see. Okay, and then let's do this one in green. Okay. Now, this one because it has both x's and y's in it, you need to solve it for y, okay? So let's subtract x from both sides. We get 2y is less than or equal to negative x plus 9. And then we have to divide by 2. Now that does not change our symbol at all. It's still going to be a less than. We're going to divide every piece by 2. Now let's talk about a nice way to write it so that we can graph it. For a line, seeing the slope separated from the x is very helpful. And seeing the y-intercept as an actual number, like in this case 4.5, is very helpful. Okay. So we're going to start at 4.5. So try to be really careful and get right in the center there. Count down 1 to the right, 2. Stay in that half mark. Down 1 to the right, 2. Really cross your region where we have that we've shaded in yellow. Okay. Then we're going to make our line, try to make it as straight as possible because we really want to see where things overlap. And then if you think about the shading here, which I'll kind of make in green, we would shade under it, which would be here. And then we can clearly see that this will make this triangle right here. That is what's our feasible region. Now, step 1 says to find the inequalities. Bam, done. Step 2, graph it. Bam, done. Step 3, label your vertices. This is the point, and I usually will make it like black or a dark color. This is the point 1, 2. This one right here, they intersect at the point 5, 2. And this is the point 1, 4. Now I know those are the exact points because I checked myself earlier in Desmos. And so if your lines don't hit those exact points, it's just because you're doing them on a device those are the answers. If you wanted to find, open up a tab in Desmos and check your work, feel free to do so, okay? So now step number 3 is done. We have the vertices, okay? So step 1 is the inequality. Step 2 is the graph. Step 3, what are your vertices? Step 4, what is your optimization function? Now that is just your f of x, y. For this 3.5a, you're going to be given that function. I'll show you in a later lesson how to find it when we need to find it. So then we're going to write that down. That is our optimization equation for this particular problem, okay? And now we're moving on to step 5. Step 5, we get to plug those things in any order. 1, 2, 5, 2, 1, 4. Okay. I put it directly underneath the function so I can keep glancing back to the function so I have that to look at. So I kind of do it just like this every time. For mathematics, a good way to be successful is to find a way that works for you and then repeat that pattern again and again. Is very helpful. Okay, so now let's plug in 1, 2. So remember, our x value is going to be a 1. Our y value is going to be a 2. Okay, so 2 times 1 is 2. Minus 3 times 2 is negative 6 for a total of negative 4. Now let's plug in 5, 2. 2 times 5 is 10. 3 times 2 is 6. 10 minus 6 is 4. Our last point to plug in is 1, 4. 2 times x is, 2 times 1 is 2. Negative 3 times 4 is negative 12 for a total of negative 10. Last step. We have to label for our values. What are the maximums? What are the minimum values? Our largest value is 4. Just write max next to it. Our minimum value is negative 10. Just write min next to it. Now that means, let's say it was something like a profit. Where will we get the maximum profit? Well, if we sell 5 of item A and 2 of item B, we make a profit of $4, $400, for whatever. It depends upon the situation. But so these are used in a lot of real life applications, especially if you study business math someday. They do this in business calculus and some other things back, and that good stuff. Okay? So this is your job. First, do we have questions about how this was done? Okay. Now, before you walk out of here today, there's 6 problems. Try to get 2 done. Okay? And then you'll have class time tomorrow to finish the other ones. You'll have all class time to work on them. So our goal is that these 6 problems are done by the time you leave at the end of class tomorrow. Okay? Now, let's look for just a minute. They've given us the inequalities. Graph them, find the feasible region, plug them into this function, and then label what's your biggest, what's your smallest. Now, some people in my other class, there are 6 equations up here. Some people were doing like the graph up here, but then showing their work down here. However you want to do it, it's your paper. Just number things so I know. Again, your goal is to try to get 1 and 2 done before you walk away. If you get some more of it, that's fine. Please make sure you're saving this as you go. A note, somebody asked me about problem number 1. This y is greater than or equal to negative x. It'll look more like slope-intercept form if you put that plus 0 in there. It's just a line with slope of negative 1. Goes through a 0, 0. Okay? So that is your job. Please work on this today. Due at the end of class tomorrow.